Yes, so I believe the recording has started now, so we can now start.
Okay.
Yes. So, yes, we were on open source verification, right? And we were also discussing about Encore.
Uh, yes, so uh, verification is actually a challenge, especially for open source as well, since not the commercial simulators are not much available, and you have to rely on open source. So there are a couple of open source resources coming up which are actually helpful. And to answer your question, how to approach with RISC-V. So if I mention my story, when I started, I did not know computer architecture that well. So what I did is I started learning how microarchitecture works, what is the approach you have, and then I started off with MIPS. So I believe that uh, it depends on the resources one looks at. So I started with reading books. So now when we speak of books, the context is like now you are reading the microarchitecture, studying about it, figuring out how it works, and then you move ahead with the manual. So two things which I referred is RISC-V ISA, unprivileged ISA, because I was not focusing on privileged ISA. So to differentiate, there are two manuals from RISC-V International. The unprivileged ISA tells the overview of the architecture, that what a general instruction based format looks like, what kind of instruction encodings you have, what kind of extensions we have. So for example, if you want to issue an atomic instruction, you want to issue a compressed instruction, if you want to have a multiplication hardware, then you can also there is an extension for that which allows multiplication and division. So the moment you have it, then you can issue multiplication instructions on the core and then run the dedicated hardware. So let's say if we speak of computer hardware, there is a lot of specific hardware to look at. Radix 4, Radix 2, Radix 8. Uh, there is a retimed hardware which computes in single cycle. So having those stuffs, one can have it. One can also implement different divider like SRT division hardware, and then there are more extensions like single precision floating point, double precision floating point, and quad precision floating point. Uh, then a bit more, and there are some extensions which are to enable that. And then there is a privilege ISA which says which mostly speaks of the control and status registers, that how they behave and how the operability of the hardware is. So any hardware, if you look at, there not the user or the software level has the complete privilege of the hardware. If I speak of RISC-V, we have machine modes, which being the highest of the priority, that mode has the highest privilege of the hardware. It can alter any content of the control and status registers which depict the operation throughout. It can read from any value, any CSR. It can be done so. In case of any interrupts, machine mode is supposed to handle in case there is no other mode allowed to do so. So given such a periphery, I could say that if someone wants to start, there are, I would say, one has to start from some basic lectures on computer architecture to understand how the microarchitecture behaves, how pipelining works, and then proceed with let's say if someone who wants to read, then there are books written by David Patterson and John L. Hennessy. So the books written by them, there are two books. One is Computer Architecture Quantitative Approach, which is really great if someone wants to understand computer architecture in depth. But then they have also books specified on the microarchitecture. They have books on MIPS, they have books on RISC-V as dedicated book which explains the architecture as well as the instruction format, how it is supposed to be interpreted and all. So those after those resources, one can also read the ISA manual. Now now to mention, the manual does not specify how your hardware is supposed to be. It just tells you the architecture. It says that if there is if there is a operate instruction which is supposed to deal with the instruction registers, integer registers to be specific, let's say, then these values of these specific fields are supposed to be read in such a way. Now you can have your hardware implemented and then you can do so. That's why the reason RISC-V is gaining traction, because of this being open source, and it does not lead to any proprietary IP. One can choose to implement in any form of hardware they want, given the IP they want to given the form of IP they want to give it to, and also the type of interpretation they can have. And that's the reason we have a lot of open source projects like Open Titan, which is even now currently a going project. Other open codes available like ibex and hornet code, they are available for someone to be in academia. If they want to start off with that, then they can go ahead with the core and use it with their projects. I would also encourage working on learning any aspect of computer architecture, even if starting out with RISC-V. It does help learn a lot in computer architecture. It's a good project to start off in academia. It does help strengthen skills. So let's say if any language known to person like Verilog, VHDL, or maybe someone wants to go for a BlueSpec Verilog or TL Verilog, which are other open source. So whichever the method the languages you use, whether it's abstract or direct, uh, l- writing hardware, and especially complex hardware, does help enhance a lot, learn a lot about the coding styles. And then once the basic is done, then one can, I believe, they can refer to the ISA manuals and pave their way out.
Okay. And so this is a multi-core system, or just a single core and trying to integrate with the hardware. So
Uh,
it's a does it have a peripheral connected and other power system everything, or
uh,
it's a kind of IP
uh,
you are
are, you,
talking about?
are you speaking of VyomMedha? The
No, other core itself.
so the moment so for in order to have multi-core configuration, then one needs a coherent cache configuration.
Mm-hmm.
So let's say even every core can have a level 1 cache, but now in order to have a coherent cache, let's say if we move to level 2, then that could be shared cache, because generally even if you speak of any architecture like CPU or GPU, L1 cache is the one which that hardware has. L2 is somewhat shared with other elements, and then L3 is shared with more. So now when you have caches like this which are shared, then in the configuration you can have it. RISC-V also allows this, given there are some memory ordering in RISC-V, which is again explained well in the manual. So let's say if someone wants to have a cache coherent system, multi-core system, like I want to have a quad core and all the cores are RISC-V, I can have the core. The RISC-V manual uh, addresses the core as heart, HART. So let's say if you have a core or a heart, so every heart can have level 1 cache, and then can have a shared cache given the cache is coherent, and some memory ordering has to be done in order for the core to work. I believe yes, this is also possible.
Mhm. So, to repeat this as an overview, so if any new generation people right from the college to very enthusiastic, this RISC-V is, making a trend and very aggressive term now. So, what you suggest, apart from this material, in open source point of view, uh, what do you suggest in starting from downloading from there to running something on their um, platform? Where do you suggest that one thing? Let's say a very junior engineer from somewhere in the engineering college wants something to do in the RISC-V. Where do you think to start with?
Well, I depend the purpose they want to. Let's say if they want to download to source an open source code and they want to use it, they can have it on their terminal. So I believe, let's say if I want to compile a Verilog code, iCaris Verilog is an open source simulator available. It has still a lot of functionalities for a lot of features for Verilog and system Verilog. Then at least I could say enough to have a synthesizable enough for a person to write and run a synthesizable piece of code in Verilog and system Verilog in iCaris Verilog. If someone is a VHD, if someone prefers VHDL, then I believe GHDL is an open source simulator. One can
What is
also
that? G,
GHDL, G,
GH,
yes. So it's all
G.
in block, and let's say if someone is in C base, if someone knows C base, they don't have to learn system Verilog and system Verilog. They can start off with either writing a C simulator, or maybe, or if they want to write synthesizable code, then they can import a library called as system C, system and then C. Uh, so it's C++ class library which allows you to have some data types which can help you model a synthesizable code. Currently, we use system C in applications like um, um, virtual platform, virtual prototyping that helps that comes up that can be called as a pre-silicon verification. And yeah, someone has texted that very later. I do agree as very later to be used. So very later is basically can be considered as a Verilog translator. It takes your Verilog code, translates that to you. One can add a compile time option to so runtime option, command line option to convert that code into either C++ or system C, and they can run it on their ends. Or let's say if someone wants to or let's say if someone wants to kind of leverage some level of industrial tools, if they have college access of the tools from the college, they can do so. Or else EDA playground serves as a real good um, platform that one can write codes and run it on the simulators there. It also supports a system Verilog UVM, so if someone wants to work on UVM methodology and write a complete sequence and they want to run multiple sequences, they can do so there with ease.
Mhm.
Yes, so could you share an example of an open source live verification project that excites you right now?
Um,
So,
live.
Sandeep, before that,
Yeah.
I think we can, before we jump into RISC-V, right? So we can, there's a course called NAN2 Tetris. So it will be really helpful to learn computer architecture. We will, I think the course is like building a CPU from gate levels. Like from initially we will build a gate, and from that we will build a CPU. And top of that, we will build software also. Everything is covered in the course, and it's a free. I think for
What
a
is,
fresh graduate, right, we can start with NAN to Tetris, and once we get understanding on how the computer architecture works, we can move it to RISC-V. Yeah.
what is that, Jay Raman? Can you repeat that? What is that
Uh,
called? NAN 2?
NAN to Tetris. NA I can
So Tetris as in
type
the
in the
name of the
chat.
game. So it's a course
We,
which helps you go through that. Uh,
I think I have mentioned those in my slides. I will let you know. Yeah.
Yeah, yeah. Share that. I think NAND that will get exciting for the lots of people, and where actually they can. You mean uh,
NAN I think the concept is like we will build a simulation and we will build a software and we will build a game on that top of that. Yeah, that's like from
ha,
NAND gate to Tetris game. That's the whole concept of that course, and it's free and it's available on Coursera, and they have one website and you can give a try. Currently, they have added a simulator in browser itself, so you can do everything in browser for free. Yeah. I will share you the link. I have those in the slides. I can We can see when we go over that.
Yeah, that's a good resource to share. Varun, do you
I
have any
think someone
question?
is.
Yes, your voice is not coming.
Yeah, that is, I think, a good point to discuss this stuff. If that has a test bench to simulate certain things, that solves a lot of things. And on top of that, let's say you have a core. Sandeepan might have more insight this. Let's say you have core which is doing all the necessary things. So it still needs to connect to the ARM base subsystem, and bus interconnects to the subsystem, or do you have your own bus platform you guys are developing? Because this is something coming in India very aggressively. That's why I'm asking. Is still you are relying on the ARM, or is coming up your own subsystem? How you guys are planning to integrate that in subsystem?
Well, for subsystems, ARM protocols come in handy. These are open source and I
Mm-hmm.
believe easy to implement. Let's say if I want to have a high speed transaction, I can have an AXI protocol do so. Now,
Mm-hmm.
if I want to have a coherent subsystem, I can use AC protocol, which is mainly for caches. So even like protocols like EPB, AXI, they have some AXI has some cache related signals, but then again the channel is the interface is bigger, as in terms of AXI has 5 channels. You're requesting something and sending data. So 3 channels related to write only, two related to read. So ACE, as far I haven't explored the ACE protocol much, but what I know is that helps us do something configuring with the cache. So as far as speaking of proprietary soft IP, we Encore has not Encore maybe has plans for future. Currently, we are using different configurations which are open source, like ARM based, because the current market needs a market has SoCs based on those kind of platforms. So in case if in a core has to be if a core has to be sold, then it should also be in a manner that it can be configured with the SoC the customers have. Let's say if you are selling a processor IP, but if I cannot configure it with my SoC, then it's a waste of money. The money I've spent on buying the IP, so it must be able to do so. So Encore has, if you're speaking of Encore, Encore also has come up with a product called as SoC generator, which when you specify that which can help you configure the not just the core but also the SoC, that okay, if you want a AHV to AHV bridge or AXI to AXI bridge or whatsoever be the configuration you want in ARM, it can be done, and then you can connect it with let's say DMA or DDR. So that can be done in FPGA prototyping and further steps ahead. So basically, in course, your unique selling point is the IP, which is the RISC-V course, and it can be uh, configured in any manner possible. If a customer wants the simplest of the core, if it say that we just want RV32I, then that is also available. If someone wants, okay, I want to use bit manipulation, which is also available as an extension in RISC-V. If they want to use single precision floating point as well, then those can be configured. And the thing which I can speak of in Encore is that Encore has different cores and which can come up with different configurations, and they are all placed against different sorts of applications. But so having said that, now if someone wants to now if we shift our focus to open source, like as in academia, or as the approach which Anushka has come up with, initiated with, as in VyomMedha, or if someone has another idea they want to do something with RISC-V, I would say it depends on the target. What are you targeting in the industry? Let's say if we speak of embedded platform, then RISC-V also allows an extension called as embedded. So now the point is, if you're moving to embedded platform, then you have to figure out what kind of peripherals you want to connect and how are these being connected. if there is a bus, the bus is supposed to order the instructions. So that is also, so I believe now working on it is two different aspects, and they both have challenges. Let's say if someone wants to have a core um, enhanced, let's say now there are now gone are the days when there were just simple processors. Pipeline processors are in the market, but also they are making it better. Let's say if branch prediction is something which actually helps, uh, so the earlier the prediction of the branch, it's better. It's better to so the efficient performances that you don't have if there in case of a mispredict, you fetch the false. If the branch is mispredicted, then what kind of instructions it is supposed to follow, that can be directly loaded to the instruction cache and it can work. Now, if we speak of machine learning applications, so the just like x86, it has AVX vector extension. RISC-V also has vector, and it is growing. So I can say, given some time, like 5 years, RISC-V will also be having a much matured vector extension, which will be used for running high machine learning workloads, and then one can also target on building a product on that direction in that direction as well.
Yes.
So,
So
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 you mean coming days it is identifying any image and processing or a video decoding, everything will. So as a silicon side, you are still there, or it is proven in FPGA and going to the silicon? Is still there is a
So,
silicon?
Balram, sorry to interrupt. So this is mostly based on verification only. So can we stick to that?
yes,
And it's
yes.
already 1 hour. Yeah. Anushka, can you please move on to next? Yeah.
Yeah, so what open source RISC-V verification projects or frameworks should engineers know about?
Well, some projects are present in the RISC-V International. They are running some tests. So let's say if someone wants to go for a membership, they can join their team and they can see some work. So the team by David Harris is working on some set of uh, test generation to see. So currently there are efforts to have verification framework in RISC-V. The present frameworks are mainly focused on checking the ISA. So if you have a YAML file which will tell you about the configuration of your core, there is I forgot the name. So that framework checks for
Is that
the
FuseSoc, Sandeep?
no, I'm speaking of a framework by RISC-V. It checks
Okay.
your YAML and then test checks and says that okay, fine, now that's just kind of an approval. Okay, it's your boxes ticks for this configuration you have, and okay, you have this stuff, these many control and status registers executed, implemented. So it just gives an approval. That's it. And then there are some tests they are used to generate tests. Currently, there are a lot of efforts for verification. I would say, I guess people are doing in their end, and I'm not sure of any open source verification framework available except for SIMB. So, Yosis SIMB is a formal verification uh, tool or methodology, I would say. So, they have come up with a formal verification framework for RISC-V. If someone wants to work on formal verification being in the academia, then I believe that's a good thing to explore. But for simulation based, like as in the normal system verilog UVM, I believe there are a lot of efforts now. Maybe we could see some open source frameworks releasing in coming years.
I think we can refer Open Titan and IBEX also
Yeah,
for
so
verification. Okay. Yeah, we can
definitely
use
IBEX
that as
code.
a reference also. Yeah.
The IBEX and Hornet code, these are actually good to see because they are RV32IM configuration based. I guess they have a C configuration as well. So if in order to start, those are good to say. Open Titan project is a really good project. I guess they are really ramping up with not just the RISC-V core, but they have other elements as well. So I would still say that if we speak of verification, first of all we need to have the scope. Where are we looking at? What are we looking at? Current, if someone wants to do that individually, I would say if you can have some bare metal approach where you can uh, have an assembly generated and then tell the core that okay fine, this is the address you are supposed to fetch the data from, then you can verify it. Or else you can take the go to the microarchitecture level, verify the blocks separately and see if it is working in that manner. Now, yeah, also to explain, Mr. Puneet has joined. So he's working on he has worked on this test generator called as RISC-V DV, which is also in current progress. So that is embedded UVM based. So embedded UVM, as in the reason this saying is that it is a UVM implemented on DLang, and the test generator generates this works on UVM, and it generates assembly based on the assembly test for the RISC-V core based on the constraints the designer writes. So I could say yes, that's one of the verification frameworks to refer to. I'm not sure if it is open source. I believe Mr. Puneet will be able to highlight on that.
Yeah, so with RISC-V being modular and customizable, what unique challenges arise for verification engineers?
If we speak of just hardware, for hardware engineers it's just hardware, but when we speak of verification, it does change a lot. So for example, if there is a let's say if you add another hardware for another extension, and now you have to see if there is any changes to that, it can also affect the control and status registers. So that means you have to actually see what happens when I run a test on that regard. If I run an illegal instruction, where is it halting to, and what it is doing. So let's just take a simple example. If we have simple control and status registers, and I have a if I have a simple single precision floating point hardware. Now if I run some tests on it, so given the so if it is to be able to run, if you are performing some operations on floating point registers, some of the registers will be changed because you are writing to it or reading from it. So that means the state of those registers do get changed. So there is a control and status register which is called as machine status, that focuses on those kind of changes, so that they keeps that has an eye on that. So there is a specific field which specifies that there is a specific 2-bit field which specifies the state of the floating point system. So in case so in case something happens, it will also store the value. So then that means if there is if there is an attempt, there is a next instruction which might attempt to write to those things, then that is supposed to be treated as an illegal instruction. So now when we speak of challenges, I say the first challenge is the proper interpretation of the RISC-V ISA manual, and then to understand that when we add a block and then the instructions issued in such a manner, what should be the consequences and what should be the actual value we are supposed to see. If I write an illegal instruction, let's say if I want to modify to a read only register, then what must happen? It's an interrupt. So now what should happen? Whether the program counter must increment to 4 bytes, 4 bytes as in I'm speaking of a 32-bit processing system. Given if you have a 64-bit processing RISC-V configuration, you can move 8 bytes. So those kind of operations, so what happens, what kind of CSRs are affected. So if I speak of my journey for now, as in core, when we are verifying those when we are writing tests for specific hardware, what we do is we also have to figure out what kind of consequences it could have to other elements of the hardware. Okay, so for example, if the instruction is decoded, fine, decoder will show these kind of instructions we have. Now what? Now whether it's supposed to be written to that, or is it, if it's not, then what is it writing to? So then I have to check properly and then we check from the reference model as well that if the values are actually correct from the perspective of the instruction which is fetched by the program counter, the register count, and also the register contents which are written to the registers, or whatever the load store operations performed during the test. So when you do that, one has to ensure everything, not just one thing but every aspect whichever possible.
So it
Yeah.
is simply developed in the C side, and or it's a completely UVM based high level infrastructure you have.
We have different verification frameworks. It's not just we are relying on one. So basically, we our aim is what from all our frameworks we write assembly tests, and this
Some
yes, and then all the frameworks help us generate the assembly, whether a randomized or directed test, and we then pass it on to the software. We load it and then we see the performance. So I believe that if let's say if someone wants to go for open source, RISC-V GNU toolchain is also available, which is just couple of steps to install, and also also a spike simulator is also available. So let's say if if someone wants to build a code, let's say basically being the simplest one, let's say I just want to have a RV32I base instruction format, so that only has support for 47 instructions. So now given with the simplest configuration, I want to see whether my code behaves properly. I can dump some instructions, assembly instructions, to the core and see how the microarchitecture is behaving, and also I can use it on Spike. So Spike can be loaded on with the ELF file. ELF is an acronym for executable linker format. So now that when loaded, Spike is a C++ based simulator. So it's the codes are all open source available. One can just go search Spike RISC-V GitHub. The codes are all available there. So that simulator starts off with that and starts executing with the configuration which you define, that I want to configure my Spike as RV32I, and now I can load the ELF on it and let the simulator run, and then it will generate some data. Now those data can be that the data from the Spike can be used to compare whether my code performed the same way, or is it something different. So I would say when we speak of CPU verification, not CPU verification is too niche. If we speak of just normal system Verilog UVM based in test bench, we also try to have a golden reference to see if in the scoreboard to check for the values, or we want to verify in the whatever the monitor reads, we want to see how it performs. So now uh, for dealing with a processor, it can be lot and lot of values. So rather than probing the signal out and checking all the values at every cycle, what this comparison of the results can prove to an efficient um, 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 verification strategy, that both the outputs can be compared and then checked, and then in case at any point if the instruction is misinterpreted, one can go back to the macro architecture and figure out what's the cause.
Yeah. So, so many say GitHub is the new resume. So, do you agree with that? So, how should a verification engineer showcase their skills with GitHub on GitHub?
Uh, well, I would say, Jayaraman, do you have any points
Yeah,
for
I
that?
think we can start to contribute open source project, or in first case we can start to develop test bench from our side, and we should push it to GitHub. Like we can start with basic protocols. So we can verify with UVM. We can use EDA, Vivado, EDA playground, Vivado, or Verilator, or iVerlog. We can use it to verify, and we can start with the basic protocols. So and then we can move it to CPU processor verification. So and the next step will be contributing the open source project. So we can contribute to Open Titan or ibex or any other projects. So the contribution doesn't mean that we only contribute only code. So we can also create a tutorial for say we can take ibex. So we can create a tutorial on how to install ibex, install RISC-V toolchain, and how to run the simulation. So we can create a tutorial. We can create a documentation. So it doesn't mean we contribution means only code. So we should start contributing from documentation and tutorial perspective. So then we will get to know more about the project. Then we can start to contribute in the projects. To know how to contribute to open source project, we can go to any open source project and we can select pull request, and we can see we can filter it with the closed one. If we see the closed pull request, right? So you can choose any PR request, and if you explore PR request, right? You get to know how they have contributed the code and how they have added the comments. So from that we can learn how to contribute code to the ecosystem, and once we learn that, we can start to contribute with the code. The first step will be like documentation and tutorial, and next step will be the code contribution. So if we add those in the resume, I think it will be like it will be added in the interview perspective. Yeah.
Even I also
Yeah.
agree to this fact, because so now just gone are the days when you can just mention a project in your resume and say I have worked on it. GitHub as a code base works as a proof. If I say I have worked on a processor design, and now if you want to see what I have done, you can just go at you can just click on the link to my GitHub repository on my resume and check the code. So that can help understand both, like a coding style and the approaches taken, and then there could be questions. So yeah, also in this thing, I would say unethical practices are to be avoided, like copy pasting codes, because that is seemed really bad during looked at frowned upon during the interviews, in the sense that whenever there is a question put on a candidate and if they fail to answer, then that makes it look like the candidate copy pasted the code. So rather, the code base should actually be proof of the work and understanding that yes, I understand system verilog properly. Now this is my code. Now if you ask me what always underscore com is, I can tell you how it is. If you ask me how about generate block, I can explain you how generate block works. So that should be my capability and its proof.
Yeah. So AI. So how can LLM be utilized to accelerate verification flows, workflows?
So I think currently most of the LLMs, right, they train from internet. So there is not much projects from Verilog or system Verilog, like good quality of projects. So to train on. So I think first thing will be we can pick any model, and I think it would be good to fine tune with our own database. So I think we need to train our own model with the system Verilog and UVM environment, so that LLM can understand and reproduce the code. I think after that, currently LLM we can use it to for code reviewing and comments, and to check the PR request and push it to the database. I think currently we can use it for this commenting and reviewing the code. Once it gets mature, we can use it for code generation, like assertions, coverage, or any system Verilog logic. That yeah. I think if you follow Ben in LinkedIn, right, so you can see how he uses Perplexity to generate SB assertions. He explained everything a bit clear. So I think it would be we can check the Ben in LinkedIn. And there is a couple of paper like Assert LLM, so where they try to generate LLM from specifications. So they have framework on how to do that. There they used to fine tune LLM model, and they are using a RAG to generate the sessions. So I think it's not open source. I think we can find a paper on asset LLM in Google. Yeah.
Yeah. So, what role do you see for reinforcement learning in verification and test bench automation?
Well, actually, this question can also be merged with the previous question. I wanted to add a point with what Jayaraman said. So now that you have asked, I can try merging out the answers. So basically, if you speak of an LLM, the large language model, which like you can see with Perplexity or ChatGPT, so now these have the core with transformers. So now when we speak of verification segment, so now currently the way they can respond in a human like manner is because of they are trained in the languages. You can ask them, you ask GPT in Hindi, Telugu, Malayalam, whichever the language you want. uh, Even in Bengali as well, all the languages I guess it has been trained in. So now the same in a similar manner, when you speak of verification, you have to train the model and to tell them that okay, this is you're supposed to work. This is how you're supposed to redirect the constraints to. By constraints, I mean though when we speak of constraints, those are the values of for the stimulus we want the test bench to pass it to the design under test, and then we check for values. So so LLMs also work with reinforcement learning with human feedback, acronym as RLHF. So when you set off when you ask about reinforcement learning, so basically LLMs also learn with reinforcement learning that whatever the human feedback it gets, it adjusts the weights internally and does all the operation. So now when we speak of the verification scenario, let's say I have a design. Let's speak of a complex design. Let's say some arbiter form or controller or something, and now I want the LLM to generate constraints for me. So now the moment it generates constraints, I say that you have to write a constraint like this, and this should be the format you pass on a template that this is what you are supposed to do. So now then you can have the LLM put you the data, uh, so that you can actually see, and then based on the your feedback, LLM will go back, adjust the parameters, and then generate the proper constraint file for you. And then you can have it as a test bench component for a layer like for the layer test bench you are looking for. So again, it's a lot of work to be done. Currently, LLMs there are efforts to train LLMs on this regard. Like for example, you mentioned ASIC LLM. That is one of, if I'm not wrong, there is a paper available. And then if you speak of some research work available, work done by some researchers at University of Bremen, that is in Germany. So some researchers are working on that segment, that they are trying to use LLM for generating floating point instructions, or they're working on some floating point units. They're trying to formally verify that. So I believe LLM can work with be used for two segments. One is either for the simulation based verification, or second for the formal verification. The formal verification is where you actually want to write assertions which can prove the temporal property. Temporal means time related property of the design. And once you actually feel that yes, this assertion can actually help me realize the property, then you can approve it as one of the concurrent assertions if you want to put, if it is concurrent. So those kind of usage I believe we can have. Also, let's say there is a test. So in verification, we have one parameter called as functional coverage. So functional coverage means that how much of the values my design has covered. So we write cover groups. A system analog allows us writing cover groups and cover points, where actually I specify that okay, fine, there is a 4-bit value. Now to look at 4-bit value can have 16 4-bit signal can have 16 values, but though some could be valid, some could be invalid. So for that, this might not have some responses for that. Let's say from 0 to 12, those are the valid values. So now if I probe that signal, I can have a cover group to see whether, and whenever I sample the cover group, I should be able to see these values being covered. So now when I see this, so that could actually help me understand the coverage goal. So my coverage goal should be close to 100% as much as possible. But now this is also depends on the bias. If you have lesser cover groups, lesser cover points, you can easily achieve 100% functional coverage. Now if you have more, now there is a trade off that okay fine, these many after based on these many values I passed the test covered, now I can see that DOT responding with these many values and then I can approve. So now you can here you can use LLMs to pass it all as a feedback. Let's see your functional coverage for this is not proper. I can approve unless and until it is uh, close to 98% or 99%. So that could be done by human feedback. But then you can ask your LLM to generate constraints in such a way that you could achieve closer to perfect functional coverage. So this is also one of the scenarios or applications you can have the LLMs for.
Yes, so Jairam, you send me the PPT. So would
Yeah.
you like to present that?
Yes. Yeah. Uh,
So I am presenting that.
yeah, I think
So
I can see. Yeah. So these are the agendas for today. I will just talk about uh, hardware DV in the age of open source and AI. Okay. So can you move to next slide?
yeah,
So these are the agendas. Like we will just explore like how can we stay relevant in the industry and what are the resources available and what are the open source projects is there and what are the tools and how to contribute to open source and LLM and verification and this constant random and also hardware security verification and community project and overall about the percent. Yeah. Can you go to next slide?
yes,
So yeah, I think this we are discussed in the starting itself. So in order to stay ahead, right? So we have to make use of LinkedIn. So follow relevant people so that we can stay relevant in the industry. And if there is an opportunity, try to join Discord, Telegram, or WhatsApp group so that you can try to interact with experts and you can learn from their experience. Okay. First thing is will be like grow your DV network. This is not restricted to DV; it's applicable to every domain. Okay. So next will be the find a mentor. If you have it may be inside your organization, your manager or your colleague, or you can find you're outside of organization stuff like for our community you can find a mentor. I think it will be good to have a mentor so that we will be stay on track and we won't waste time exploring the things we don't want. So our mentor will guide you on how and when to approach, so it will save your time and you will gain expertise from a mentor. And also always believe in cold email and text. If you see any job opportunities or internship opportunity, just shoot a mail. So mostly you will get a response from them. I think that's the thing. And use Substack, Reddit, and Quora to uh, see discussion about topics in VLSI or DV or anything. So I try to use this platform to stay relevant to the industry and see what people thinks and how they are approaching this thing. And one more thing is like if you are a college graduate or a fresher or experience, just if you want to join any company, suppose let's say if you want to join any top MNC company, right? So just keep track of their job description, see what the requirement they are posting. So suppose if they have a frequent post on DDR or SRAM, so that uh, collect the keyword and try to gain expertise in that and do some projects and make it open source. And if you approach them when they post again, right? So I think chances are high that you will get selected in your dream company. Okay, so always keep eye on job description, and by keeping track of job description, we can also know the industry trends and what companies are looking from engineers. Yeah. Next slide, please. So I think as we talked in before, right? So this is NAND to Tetris course. I think before jumping to RISC-V verification, process verification, anything, I think everyone in VLSI or software field also, we can try to do this course. If you are a college graduate, you can pick one semester and you can try to start learn this course. I think the concept is like we will start build from NAND gate, so we will build up NAND gate, OR gate, everything with an AND gate, and we will build the CPU. So on that, on top of that, we will build the software hierarchy, and on top of that, we will write a program to run on the hardware which we design from a NAND gate. So here we will the course will follow like you will basically build a gate, and on top of that you will write a program in software. Like here you can create a Tetris game and you can run a simulation, or you can create any game which you like. I think this is available in Coursera also. It's free, and
Is
I
it
have collected. Yeah.
schematic, Jairam?
Yeah.
Schematic, you bring from schematic to the RTL.
Right. Yeah. Yeah, actually, they will guide us from starting point itself. So they will tell how to design a mux using it. Then they will ask you to design multiplication adder circuit. So they will give an example, and they will guide you through to design every component and how to stitch CPU. So everything. So initially, we have to download their resource and we have to build it from our computer. But now they have ported everything into a web browser. So in web itself, we can create, run simulation, everything we can do. I think this will be a good course to start for everyone to understand computer architecture and how this hardware, software interacts. Everything you get to know from this course. Yeah. And I have collected some DV resources and I have pasted in my GitHub page. You can check that. So to get started on DV, right? Uh, can you go next slide, Scott? So get started on DV. First thing will be like focus on LRM. So go through the LRM and see what are the syntax and variable is available, and you can refer Crispy System Relic for verification. That will be a good book to get started. So this is to get started in design verification. For system Verilog, you can use Crispier and you can refer LRM to learn the system Verilog concepts. And for UVM, you can follow Srivatsan Vasudevan book, Practical Steps UVM. So it's a good book, and he has GitHub for the code that he has mentioned in the book. So I think it will be a very good resource to learn UVM. And for SV, I think you can use Srinivasan Venkatraman book. I think it will be a good to start for assistants also. I forgot to mention here. So and next will be if you want to get started on Coco TV. I think there is a book for Coco TV. I think this was written by the author of Coco TV itself. Complete course RTL Python for RTL verification, and we can refer
I had a
Coco.
question.
Yeah.
Yeah, so the importance of object oriented programming for learning verification.
Yes, that
So,
everything will be covered in system Verilog or verification book. So OOPS concept, everything will be covered in that book. So yeah,
yeah, yes.
so
Yes,
it's
Jayaraman,
to get started. Yeah, yeah.
before you proceed, I just wanted to ask the book you mentioned about Coco TB. Is it
Ah,
the author? Is the author Ray Salemi you're talking about?
yes.
Oh,
Same
okay,
guy.
okay, okay.
Yeah, he wrote this book. Yeah, I think it will be good to get started on CocoDB. Yeah.
Okay.
So just have one question, like this CocoDB has momentum in industry started. We just started, but somehow relying on so much on the simulation side. But our traditional simulation side. So you guys, Jairam and Sandeep, can add one point. Like you guys started some really implementation side of this CocoDB. or it's still in? Uh,
I think I have tried CocoaDB, but it is simulation is bit slow compared to system Verilog. I think there is a CocoaDB 2.0 release is coming up. I think they are planning to speed up the simulation. I'm not sure about how. I think Tensorflow they are using CocoaDB. I think that I'm not sure. Other than that, I'm not sure how in
it's
industry
kind.
level. I'm not sure how they are. Yeah,
It's completely Python based, Jairam. How it is aligned? Like since you are trained, just give
CocoaDB.
me
You mean?
words. Yeah.
Yes, it's completely on Python. It's Python only.
So how it is hardware is integrated? Like what is the interface for that?
So they are using VPA, like Verilog Producer Interface, to interact with the simulator. So it will, I think, from Python to C++, and it will interact with simulator for controlling the simulation. Yeah. CocoaDB is like directed test bench, like it will be like Verilog test bench, and on top of that there is another library called PyUVM. So it will look exactly same as a UVM. So UVM, but in Python framework.
Mhm.
So just to add one more point to this, so basically, if with SVUVM framework, so that is available with commercial simulators, and then again it's kind of expensive, because if you want to purchase a simulator like Xilium or VC, VCS or Verdi. So now this CocoaDB is kind of is more of an open source option. If you want to verify and if you want to do something a bit faster, then CocoaDB could work. So it's again the DPI is actually being used to interact with the binary of the Verilog. So it's not. So if you speak of the normal logic simulators, they have different binary set, and they have the setup for interacting the test bench with the Verilog files. But here, if you speak of frameworks like CocoaDB or System-C, you might need to interact with that through pass on the signals. So now Python is again a foreign language to Verilog, and DPI and VPI allow foreign language to be passed on as routine to Verilog file during simulation. So that's how it interacts, and that's how it passes on the data.
What is the debugger here? Like our still we have to use or any open source debugger can. How do you see the waveforms?
You
I
can
guess,
use GTK wave.
yeah, I was
It we
about to
can
say
generate
that.
VCD dump, right? We can use GTK
Uh,
wave or
Yes.
GTK.
So
yeah, we
once
can use.
VCD dump is available, then any
Mhm.
waveform viewer could be used.
Right.
All right.
So next is like we can actually see how the experienced people they used to write test bench. So we can refer this OpenTitan project for SOC level verification, and you can see IBEX for IP level verification. So they have very good infrastructure on
Sorry
how
to
to.
interrupt.
Yeah, yes, please.
Yeah, I have a question on CocoaDB.
Yeah.
So have you tried any constraint solver on CocoaDB?
Uh, CocoaDB, I think we need to use, there is a library called Py constraints. So we need to import PySV constraint. I think I couldn't get the name. So we can use that another library inside. We can pull into CocoaDB and we can use it.
So
Otherwise, we
how
can
would that? How
use
would that like
random keyword with valid range. We can use that also.
what kind of constraints will you be able to solve with high constraints?
Um, I haven't done much on that, yeah. But I know that we can use PySV constraint. Is that?
Because
Uh,
mostly like when I talk to CocoaDB users, they
mm.
mostly tell me that okay, constraints are not necessary and that kind of excuses are there.
Otherwise, we can use constraints with Python language itself. I think with this rand init with range, we can constrain the stimulus with
Isn't that
Python itself. Yeah,
intuitive? Like that kind of things are possible in any language. For example, C++ will also support it. So, I mean, what's
right.
the advantage if you don't have proper constraints? Why to use CocoaDB? That's the question. Like when I move from Verilog to system Verilog, then mainly I get assertions, constraints, and coverage.
Right.
And if you take out constraints, then coverage means very little.
The coverage also they have implemented, I think.
Yeah,
I
but if you
checked
don't
the
have constraints, then what does like constraint without constraints coverage doesn't bring me much.
Right. It's the thing to use is like it's open source and it's currently it's in development. I think currently it won't replace existing UVM SV framework. So it's a start. I think with they are planning to upgrade the CocoaDB with to include every features and they are planning to reduce the simulation time also. If you see the GitHub request
So
issues,
some
right?
data
We can get
there,
to know that.
Chairman,
Yeah.
some data there. Like one thing, if you are using VPI or PLI with any simulation, the simulation is going to get slower by a
Slow.
factor of 2 or more, right?
Right, agree, yeah.
And then Python as a language being an interpreted language, it works something like the benchmarks say it works 57 times slower than C++.
Right.
So I mean, like how do you really end up making an efficient test bench in Python if it is 57x slower than C or C++?
I think that that is under development by the. I think there are a bunch of experts. They are working on this core team framework. I have just used the framework, but I haven't developed actually. So I think to use the reason to use is like it's open source and we can run simulation in our local system. That's the thing currently we are using, but we hope that they will improve step by step. Yeah.
Okay, like so long as it is Python, it cannot be fast. That's it.
Hmm.
All right.
So yeah, I think we can take reference from OpenTitan and IBEX. Currently, it support to run design verification, right? So it uses a commercial simulator. So currently there is no support to use open source simulator. Can you go to next slide? So other than this, there are many interesting projects framework available. So one thing is like SV unit. So this is similar to software unit testing. So here SV unit is a framework where we can verify the suppose we are writing a driver. All right. So rather than we wait for entire test bench to ready to run a simulation, we can test the UVM driver with the unit testing. So how can we do is like we can use SV unit framework to verify the UVM driver and we can verify whether it's working up to the expectation. So this I think this is an interesting project. And another thing is Road. Here I think they are using Dart program language to design and verify HDL thing. And another one is like a Wavedrome LLM. I think we know Wavedrome. We can this is used to generate a timing diagram. So here they have added a LLM functionality, whether it will create a timing diagram using LLM. So and next one is like a PySlang. We can use PySlang to write a test bench linter so that uh, we can see whether the test bench created follows the certain rules. So we can write test bench rule using PySlang, or we can use variable from Google. Anything we can use as a test bench linter. Okay, there are
So
many such framework.
Sandeepan,
Yeah,
Roy,
yeah,
you have some question?
Yeah, so Jairam, I wanted to ask you about SV unit. So
yeah.
if we look at a test bench from a layer test bench perspective,
Okay,
if I have a sequence which will randomize sequence item and have some constraints, and then the driver will do the handshake and pass on the data. But now when you said that now I can use SV unit to do so, so how am I going to pass some randomized data or constrained data? Like, how do I pass the data to the interface?
In SV unit, you can pass your stimulus directly. So the framework, right? I think driver and the sequencer hookup is there, right? So what SV unit does is like I'm just thinking overall, like there is a connection, right, between sequencer and driver. So SV unit, what it does is it will hook up that sequence item export with the SV unit, and it will pass this stimulus to driver, and it will get the output. So we can hook up we can hook up any UVM component with the SV unit. So they in their library they have support for this. So we don't need to write anything. So we can just import the library and we can create a unit test.
So
I think
yeah. So my question is like, how does it look like? Like if you speak of a normal SVUM test bench, you have transaction item, sequence class, driver which will do the sequence item dot get next item method call, and then the sequence will have, okay, I will do the wait for transaction done. If I'm forgetting if it is actual name for the method, and then in your agent you do the connection that this dot connect equals this dot export. So now you said that SV unit can do that. My question is now, how do I picturize SV unit? Like what kind of code do I write?
see this is like you can verify that we can not only driver, we can verify coverage, monitor, everything we can verify. See, for example, right, we can just Google. I think EDA Playground has example for SVM. Can you do this?
Sure thing. I can. Now I remember
can
that
you?
EDA Playground has some examples.
EDA Playground has this support, so you get the basic idea, right? So
Okay.
you can pick up this. Yeah.
Sure thing. I will do that then.
Yeah. So okay.
So should I move to next slide?
Yes. Yeah. So with this, there's an opportunity for hardware verification. So see, we can see people design RISC-V based CPU and many such a thing, but most of them have a direct test bench, or most of them doesn't have a test bench. So we can pick any design and we can do verify, and we can publish it in GitHub. So it will add our value also. So to how to pick a project, right? So one way is like we can go to GitHub and we can search for let's say we can so here I have searched for CPU, and language I have chosen filter as a Verilog. So if you do that, right, so you will get a bunch of projects. So you can filter it by star or popularity. So then you can pick any projects with good documentation, and you can start to write a test bench. So by this way we can practice by writing a test bench, and also we can use open course. They have a bunch of different IPs, so we can pick up. They have actually good documentation for all IP projects, so we can pick up any IPs, and I think most of the project has directed dispense. So you can take that as a reference, and we can start to write UVM test bench for all the IPs. So it will be a good practice, and if you do that and if you publish it in LinkedIn and GitHub, right? So you will it will be like a bonus point for in your interview. So yeah.
Jairam, I think
Yeah.
this is one of the oldest community open course. They are still contributing there, or
No,
it's
I
just
think currently they it's stopped. They are stopped contributing, I think. Yeah.
oh, okay.
But we can pick up the older. Yeah.
Okay.
We can pick this, and they have good documentation and this thing also. Yeah.
Yeah.
Can you go to next slide?
And to say this RTL is available, a lot of.
So these are the currently we have these tools for verification. We can use EDA Playground. In EDA Playground, we can run UVM or CocoTB. I think with this student ID or corporate ID, we can access commercial simulator. And next thing is like Verilator. Verilator, we can run CocoDB by UVM. And recently they have added support for UVM. but they have, I think they are supporting basic UVM. I think constraint randomization and this thing, I think this they are yet to implement in very later UVM, but we can write a basic simple test bench in very later with the UVM. And another option is Vivado. I think Vivado we can use it to write Verilog design, and we can use UVM to verify using Vivado simulator. I think, and we can also use Iverilog. Iverilog supports directed test bench or CocoDB or PyUVM to verify the design. I think if you see that, we can use Vivado with UVM will be a good choice to run verification thing.
You need a student ID, or just you can use with the personal ID to download that Vivado. Vivado,
We
what
can
is
use personal thing. Yeah,
Vivado
it
can be
works.
used with any ID.
okay?
Yeah,
It will just download the whatever the hard software pack you want. Let's say just
Mm.
Vivado or Vivado plus Vitis.
Mm. Yeah, Vivado is good because it had a debugger too, right? You can see the
right,
way.
right.
Yeah.
Yeah. I think mostly we can use Vivado for any projects. Yeah. So, how to start to contribute? Like as we discussed before, right? Uh, uh, the challenges will be like projects like IBEX or Open Titan, right? They are using commercial simulator, and there most of the projects lack of documentation, or there will be issue with installation, so that we will give up this thing. So we can take this challenge as an opportunity, and we can use it to contribute to your open source project. So one thing what we can do is like we can port the project structure from a commercial to open source simulator. Like you can use PyUVM to verify projects which verified with UVM, or we can port the project from any commercial platform to EDA playground to run with the UVM. So we can do that, and we can also contribute by creating a tutorial or writing a documentation. By this way, we can slowly we can start to contribute to the open source projects. Yeah. Can you go next? So yeah, as we discussed before, right? We can also contribute by documentation or creating a tutorial like installation and running the project. So this will really help the community to get started and to get once you get familiar with the environment, and as I mentioned, we can go to any projects, go to any closed pull request, and you can see how they have done. You can do the similar thing. Can you go next? So I have done some couple of projects, like one is the RTL to UVM, which is like we will pass top level test bench. So sorry, top level RTL file. So using PySlang test bench later, I just extract the input and output ports and parameter information. So with that, I will say that this tool will generate a basic single L agent test bench. So if you pass a switch like Verilator or EDA Playground, it will create a test bench which is compatible with Verilator or EDA Playground. So and I'm planning to extend with Vivado. So if you pass Vivado switch, right, so it will generate test bench which is compatible with Vivado, so that we can run simulation directly on Vivado. So
So
installation, so setup thing will get ruled out. Yeah.
it's kind of a script which generate RTL and integrates into the UVM stuff.
No,
Or
no. It will take RTL as a reference, and it will generate a test bench. It will
Mhm.
generate sequencer driver, agent, everything it will generate. And I try to hook up LLM for driver logic. I think for simple design, LLM works. For complex design, it couldn't generate UVM driver logic. So, but it will, with the LLM switch, we can generate a UVM driver and monitor logic. Yeah, I think based on complexity, LLM can generate driver logic. So other than that, we can uh, generate a test bench skeleton, and we can from there we can proceed to generate UM driver or monitor and score for it
yeah,
from there.
the basic framework will be there. Okay.
Ah, yes. Yeah.
When you speak of this thing, when the framework reads the top level test bench, top level
Mm.
hardware Verilog file. So the first thing it could be doing is to whatever the inputs and whatever the outputs ports are, that could be converted to some signals in the interface or some hardware, or maybe some writing logic there. But then how does the test bench figure out the type of constraints it is supposed to have? Are you passing any parameter that this is the value you're supposed to do?
No, actually, it won't generate constraints. So it will generate basic test bench. Okay, it generates basic structure, and it will just randomize it will just add rand in it to the input stimulus, and it will just run the simulation. So idea is right, like it will help to get started quickly. Okay, so it will create a basic test bench skeleton, and if you want, we can use LLM to generate driver or monitor logic, and it will generate, it won't add any constraints or assumptions, so that we have to add.
Okay, so basically you are so you are developing this, are you?
Yes,
Okay.
yeah. Currently I have done it for Verilator and EDA playground. I'm
Mm-hmm.
trying to do for Vivado.
Oh, okay.
So it will create makefile, flist, everything it will do. So we need to jump in and write driver logic, and we will get it run. That's the thing.
Oh, all right.
So next thing is like LLM VLSI. This is like a, simple tool. Like we will just give a prompt. So from the prompt, it will extract a response which has Verilog code, and it will run the simulation, and it will try to summarize the simulation by reading the simulation log. It's this just I just tried with this LLM thing. You can just give a try, like how it will works. And in future, I'm planning to add a feedback loop where when the simulation fails, right, we can loop it to LLM, and we can ask it to rewrite the failing syntax, and it can self-correct, and it will run the simulation, and it will summarize this code what we are doing. Yeah,
So
I think I've done it for, yeah.
so where are you sourcing the LLM from? Is it like OpenAI or Llama model you're
Uh,
using?
this I have used Gemini, Google Gemini model.
Oh, Google. So is it available open source? Can I just download, install it on my WSL?
Yes, I think for Gemini, you need to get a API key. That's it. You just need to replace the API key. You can run this thing. Yeah.
Oh, okay. So we are supposed to just put that API key on the terminal.
Right. I think you need to just update in my script, and you can give a run. That's it.
Oh, all right.
Yeah. So can you move to next slide? So I think not this one. Can you go up? No, yeah. I think 12. I think 12 or 11 slide.
This is fine.
11. I think slide number.
Okay.
11. Next. Next. Okay, this one, like so I just ported from, this is one example of, I said, like contributing open source. So what I did is like I just downloaded the code, and I just ported to EDA playground. So now, right, you can run this processor UVM verification in EDA playground also. So you can contribute by like this also. So by porting from commercial thing to EDA playground. So this also, it's a part of contribution. Can you go next? So these are the couple of papers we can get started with the LLM verification. Asset LLM, I think I have talked it previously. So it generates assertions from specification. So if you read the paper, they will go through the framework which they have worked on to generate assertions. And the first thing is like a LLM for DV. It's a open source project, and you can see it in GitHub. So what they do is like Sandeepan told, right? By getting feedback from coverage, it will generate stimulus, and it will run simulation, and it will go on a loop. So to get started on LLM and verification, LLM for DV paper will be a good start. Just read the paper, and you can download the open source project. I think they have written the test bench in CocoaDB. So you can write, so you can run with open source simulator. So you don't need any commercial license. So you can just download the repo and you can give a run and you can see how LLM works in DV perspective. Basically, it will read coverage bins, generate stimulus based on those input, and it will run it on a loop. Yeah. Can you go next?
Jaraman, so is it
Yes,
like
yes.
does it so whenever the coverage report is evaluated, so does it like call the function get coverage and sees if the cover group has this much percent, let's say 80% coverage.
Yeah, right. So here in LLM for DV, right, they are using, so initially they are starting with bin description. So
Okay.
along with the prompt, right, they will give the exact bin description with the prompt and they will generate a stimulus and they will extract they write some script to extract the stimulus and they convert it to CocoDB stimulus and they will pass it to DUT and they will read from a coverage and they will update the prompt and they will generate stimulus. It will go on loop.
Okay, so
If you
this
want, we can open. If you want, we can open the paper also.
yeah, we can read it. We can read it afterwards. It can be taken as a takeaway from this
Yeah,
podcast.
right. And yeah, and these two links we can LLM for EDA, right? So this has a list of papers where they are using LLM in design and verification, EDA automation. So this, if you go to this link, right, we can see a bunch of collection of papers which involves LLM in verification and design. So next link, AI for EDA, it has a collection of papers where they are using AI in different areas of VLSI, like physical design, placement and routing. So it has bunch of papers which is available online. Yeah. Next slide, please. So beyond constraint random, so here, right, so I came across this couple of papers, so where they are trying to replace constraint random verification with reinforcement learning. So here, it works similar to LLM for DV. So where rather than generating a random stimulus, so this reinforcement learning verification environment, right? So it will basically reinforcement learning will work with reward or loss. Okay, so we can program reward with certain coverage bins. Let's say we can give a reward if this certain coverage bin hits. So what this system does is it will generate a stimulus, run a simulation, and it sees whether the required win has hit or not. If it doesn't hit, it will modify the stimulus and it will run again and see whether it hits or not. So in this paper, they have experimented with, they have compared constraint random with this reinforcement learning, and they have achieved pretty good results compared to constraint random verification. So with this reinforcement learning, right, so we can uncover the difficult path, right, in quicker iteration than constraint random stimulation. If you have a time, it's and also it's an open source project. They are using CocoDB to run this simulation. We can you can read the paper, download the VERL Python library, and you can run. They have a bunch of examples. You can give a run with reinforcement learning and without reinforcement learning, and we can compare the logs, and we will get know. It will be a good experiment to see how it works. It's we can run it for free with the CocoDB.
Gentlemen, I have a few questions here.
Yes, yes.
Okay, so one of the ideas, the very basics of constraint random verification is that like when you're running random stimulus, see, like when we are talking about hitting the bins, then
Right.
it is kind of, it works opposite of randomization. Like bins are created by human beings. Like for example, like old days, pre 2000, we used to write directed test cases, and directed is not random. and we can write a few test cases which will be bin specific. Like we want to write certain, we want to either have port coverage, or if we have something similar to functional coverage, then we'll just identify the test cases and we'll write those. Okay, so in some way, functional coverage is replacing, uh, like it's not replacement, but it is the same thing as writing directed test cases. It works like functional coverage, while it is a matrix of having done enough verification, but it cannot be goal in the way that you write directed or guided test cases which hit the bins without enough randomization. Are you getting my point?
Right. Yeah. Okay.
So, like, I'll tell you, 10 years back, I had learned from one of my colleagues. I mean, they were working on a different project. But what they had done was they had constraint random verification. And then the constraint random verification, as soon as it hits a bin, they had a Perl script to find it out, and they'll add a constraint in such a way that that bin will not be hit again. And that way they were doing, they keep adding constraints so that they work through the functional coverage as soon as possible. But in my view, it works against the very philosophy of constraint random verification.
I would like to respond to this. So, based on my knowledge on reinforcement learning, the philosophy we use is an active critic method, which means like the basic thing of reinforcement learning is there is an actor, there is an agent which will be walking through, and it will be interacting with the environment where it is put in, and then based on the actions taken by the agent, environment will give the agent some reward. It could be positive or negative. So now what we do is that so the reinforcement learning is about to let the agent understand all kinds of scenarios and see whichever the policy it takes. Policy means whatever the method to achieve the optimal goal, whichever the policy helps yield the optimal best reward, and then that could take it. Now, given the principle you said, I do understand why we need it. But now, when we speak of a reinforcement learning framework, what I understand from the work from VLSI, the paper, so it's just basically that they needed something for the environment as an environment to give it to the actor, to the agent, that if you're doing something, if you have this thing coverage, and now your goal is to help us achieve functional coverage fully. So now if your constraints is not in that direction, I cannot rely on a coverage, and hence they might have added the environment in such a manner that this gives the agent a positive reward. The more times it tries to hit a bin, a complete number of bins of a particular cover group, and that could be the philosophy I believe they have taken.
So what else could be a reward? I mean, most of the people, when they use it, they'll probably make functional coverage a reward because that's one of the goals before you take out.
Well,
We can also, I think we can also use it to cover the uncovered path. I forget the coverage. Like we use
Code coverage,
in coverage there is one
path
like
coverage.
equal to greater than symbol will be there, right? Like one, if it achieves state A, it has to achieve state B.
You mean transition coverage? That's in functional
Transition coverage. Right.
Yeah.
So we can also use transition coverage to achieve the uncovered state. So that the agent will generate a stimulus so that it will cover the uncovered path very quickly, comparing to random constrained random. And if in case of
saying, like whatever we are doing, how do we make sure? Like I do see there could be some benefits of having this kind of help or reinforcement learning, as you call it, to modify or to help generate the stimulus. But how can we make sure that it is not doing something which actually is stopping me from being enough random?
Do you mean to say that the reinforce
Uh,
so the when the agent works on the generating random stimulus, so now is it supposed to be that the analysis from the analysis point of view, that it's not generating enough of the leveraging enough of the randomization solver to generate me those values as
See,
faster.
most of the reinforcement learning, it's going to modify the constraints and make the randomization go in a particular direction.
I agree.
Now,
Yes.
what is there for me to make sure that, because all this will be in a way, like, because some artificial intelligence agent is doing it. So, like, for example, when I go to Google and I use Gemini to figure out like some concept, so it will tell me AI can be wrong, right? So when
Yes.
I let AI handle my constraints, it will have a fine print. It could go wrong.
Yes, it could.
s-
So I mean, if ultimately, as a verification engineer, I need to take responsibility of my verification. But if I'm letting AI do this part for me, then how can I make sure that it is not um, modifying or biasing or fine tuning constraints in a wrong direction,
Well,
which
then,
is which is actually
uh,
masking some bugs which could be found out otherwise.
well, one approach
so
I could say is that the reward which we pass it to the agent, it can be
Whatever
anything.
the rewards are, Sandeepan, like, that's the
uh,
basic difference between directed and randomized verification. Rewards, if we select the rewards, then the rewards are having human intervention.
Uh,
So, for
yes.
example, if I tabulate all the corner cases, then I'm doing it as a human. I will not be able to. That's the thing with the complex systems. I will not be tabulating all the corner cases, and that's the thing about randomization. That things that you are not able to figure out manually or through a human process, those things have a better chance of getting hit because of the randomization. Now, even if you are putting rewards, that's a human intervention. And for complex systems, that human intervention is going against the philosophy of randomization.
well, the human
So
intervention. Yeah, please go ahead.
So here, so thing is like this LLM and this reinforced learning are completely different. So LLM is like it will LLM is basically like a text predictor. Okay. So we here in this paper they talked about reinforcement learning. So here it will if we need human intervention, like we will give the reward when it hits the certain area. We will say the reward is one. Otherwise, the reward will be lost. So here, it depends. So based on the reward, it will generate a stimulus so that it can uh, achieve the it will make the DOT to hit the state.
So, for
This is what.
example, you talked about transition coverage, right? Now,
Right, right,
transition coverage hitting a particular, say, state in a state machine. Uh,
right.
Again, it is a human intervention. There would be so many states that
Mm,
I will not be, because of the complex. For example, take instruction reordering in RISC-V processor,
mm.
right? Now, if I try to figure out certain hazard conditions based on the sequence of instructions, then those are human interventions. Those are the hazard conditions I can identify with my limited human capability. But the system is too complex for me to figure out all the hazard conditions. And that's where randomization is important.
Well, I
Yeah.
believe the point is
Mm.
so the one you said that when we have a human intervention for a reward, that is I understand as reinforcement learning with human feedback if the algorithm is coded that way. or else the so basically when we speak of reinforcement learning, the environment, we need to have complete information of the system here, in the sense that when we have the agent and environment coded, it has to be in a direction to say that, let's say if you have a constraint which has, let's say, to complicate, let's say there should be some implication operator, now given that kind of scenario, so it must be able to figure out, so now it's supposed to figure out that this is a scenario, and out of all these combinations, if implication operator has been applied, then this should be the this should be the way constraint solver is supposed to come up with the value. Now if this happens, then what should be there, and so now there could be a specific engine to look at this, give up the feedback as an, so this could be integrated to the environment. It could let the agent know that, see, this is what you have done, and now you go back and do that, so without the human intervention. So but again, for some training of the model, initially it might need a human to do so, but then given the rewards and the adjusting, I believe the model can itself can do that.
So in the end, how can I make sure? So whatever papers I have gone through or I have seen on artificial intelligence or machine learning as an agent in verification, they all talk about meeting functional coverage or code coverage goals earlier than otherwise it would have taken. Okay, with just with complete randomization without an agent. Okay, but that I think is not the goal. If I can have a system which can write directed test cases for me, and obviously AI can do that, right? Then I can with those directed test cases, I'll be able to reach functional coverage and code coverage goals much earlier than randomization. But that's very much against the very philosophy of CRV. So I don't see, like, whatever AI is bringing on the table, they are trying to argue with respect to either code coverage or functional coverage. These two goals getting met earlier. Okay, but these two are human interventions. Code coverage may not be, but functional coverage certainly is. But code coverage is anyway not a great matrix for having complete verification done. Okay, so as far as functional coverage is, it's a matrix, but it's not a complete matrix. So you let the randomization do its job, and then when it's doing its job, you have certain, say, milestones which are present in terms of functional coverage. So it's meeting those. But if you are biasing your system towards meeting functional coverage goals earlier, then you will be missing real bugs. That's what my point is.
Yeah. Maybe here
Yeah.
my point is, maybe one way is, this is at present I think the commercial tools doesn't support. The only research came through that CocoaDB, right? So the other way of validating this is to bring this into the a regular and a normal simulation to see the difference between these. Then if this behind the constraint random is covering a a critical path which is not covered in the regular simulation, then we know this agent is validating and reinforcing behind our random constraint. So
No, it's not true. Like there are commercial simulators which also claim to have AI agents.
they
Oh,
are now, I think at present we don't use these actually, but maybe now they are trying to enforce these things to see how we're validating. But at one point, design has to, agent has to understand the what is the critical path which is down the RTL line which is not covering. That's a whole idea is, in the regular format we are not covering certain cover bins, then we have to cover certain areas. So the idea behind is to see the critical path. I think that's all my understanding here.
Well,
So like will the agent be logically analyzing the critical
Yeah,
path? I don't think
logically
I don't think
understood.
it can,
Then,
because
yeah, if
after
that
a certain.
doesn't, yeah, if that doesn't understand logically, then how does it knows that, based on your inputs, how many pins, how many iteration it is covered? How does it knows that? It has to logically understand that.
So if it's able to do that logically, then probably you will be able to run a formal verification tool on that, right? And formal verification fails because logically you can't understand every path. The systems are so complex. So when it comes to logical, and that's why I'm emphasizing AI agents and machine learning agents will not be using pure logic to understand paths. That's for formal verification tools to do. And formal verification tools we know they cannot handle every kind of complexity.
If it doesn't understand logically, then how does it
So,
gets the
so
granting?
here, so in this case, it will do by trial and error only. So it will try with the stimulus. If it doesn't work, it will change the stimulus and give a try. So that's how this reinforced learning agent reward works. So that's
So
how
I,
it
I
can
don't
figure out
know
the path.
what they
Yeah.
did with CocoDB, but what I know,
Mm.
the commercial tools are doing it by modifying the constraints, or
Oh, okay.
actually tightening the constraints rather than loosening the constraints.
So here, rather than changing the stimulus, they are constraining it to generate within that constraint.
Yeah,
Generating
so
stimulus within the
they
constraint.
are
Oh, okay.
they are biasing the randomization by looking at the rewards, whatever rewards you have put. But
Mm.
again, my point is, if you are putting rewards, then those rewards are a human intervention.
Yeah,
Right.
we understood
Right.
this point.
Yeah.
I think, yeah, move further. I
Yes.
think this is something need to be done the research behind this. Yeah,
I do agree that this point which you have come up with is currently it's not, no one has
yeah,
done
It's
so.
just an experiment. Yeah.
Yeah,
Just
yeah.
I believe functional coverage could have been chosen because it's kind of an easier path to choose, because now the moment you can use a coverage function coverage percentage, that can then tell the agent that, see, now you go to this path and this is your reward. And now for your optimal, so whatever the policy you take, policy means whatever the set of actions you do to achieve your goal, so whatever the policy you take, that must yield 100% coverage for all of the cover groups I mentioned. So the moment I add more, then the constraints should be in that direction. So
Uh,
now, in order to solve the problem which you have mentioned, that now to verify whether it's actual the constraint random verification is on that path, there should be an engine which could actually be able to figure out all the paths and all the relation which has been mentioned with the constraints in all forms, whether I write distribution, or whether I write implication operator, or any other thing, set membership, everything must be solved and then check that these are the values being generated. And now that should be the reward, that with this much test and these many transactions you were able to generate this. So now, in order to have a reward, positive reward, you must generate a number of transactions so that you could actually cover all those scenarios. Whether you add rand qualifier or rand c qualifier, at least these many scenarios are to be generated with the constraints. And then maybe you could have the agent work on that direction, and then see if it actually achieves functional coverage.
yeah. I
Let's
think
see, the constraint solvers themselves um, have a have a like character or attribute that whatever constraints you have provided, they will try to do uniform randomization for the given constraints.
yes.
Okay, so for example, let's take RISC-V DV, which is you mentioned it earlier. So it's a random instruction generator for RISC-V, right? Now, so long as it is not so if you look at the RISC-V DB constraints, you open the like it's a project which is the repository is owned by Chips Alliance now, but earlier the project was supported mostly by Google, team at Google. Now, if you look at the constraints, you open the files and look at the constraints, they really the constraints are following uh, the ISA architecture. Okay, so for example, if the ISA architecture says that a particular instruction, the destination register cannot be R0 or the 0 register, right? So there will be a constraint over there that destination register cannot be this register. Now, after that, it's for the constraint solvers, and the constraint solvers try to do the best job by bringing uniformity in the randomization. Okay, so, and again, randomization is such a, like, if for example, there are VDD solvers and there are SAT SMT solvers, the randomization, there is ongoing research in the SAT SMT solvers, like how to make the results as randomized as possible. VDD solvers are much better in terms of uniformity in randomization. But randomization is such a thing that you cannot, for example, learn. You know, given the data, you cannot kind of make a learning out of it that this is enough random, because that's the thing about random. Like there was a Dilbert joke about it. So there is a random number generator which is saying 7777777. It continues to say 777, and somebody asks, "Is that random?" So then Dilbert replies, "That's the thing about randomization. You never know like whether it's random or not." Because it's also possible to have 7 consecutively 20 times in a random scenario, right? So what my question is, like, if you are, and that's what the AI agents, like all the commercial simulators, etc., they keep claiming that they will fine-tune the constraints. Now, fine-tuning of constraints is going to bring some bias to the inherent randomization or the uniformity in the randomization of the tool. Whether it is going in the right direction or wrong direction is a kind of very complex problem to figure out whether it's going in the right direction.
But my question is, let's say if I have a constraint for a 4-bit value variable, I say that now this value inside 1 colon 10. That means it will take away values 1 to 9. So now the moment I randomize it, I'm supposed to look at those. So I'm supposed to see those values when I print that through UVM dollar display or UVM info.
Sure.
Yeah, so that means it is in the right direction, if I'm not wrong. Now, and how do we determine that if I say from 1 to 10, how do we determine the direction, whether you're going correct or whether it's supposed to be in this solver should be having this value before this? If it is rand, then it might not generate. But if it is rand qualifier, then it might generate a couple of numbers repeated times. Let's say 4, it might come by 3 or 4 times. But if it is RAND-C, then I am expected to see all those values.
So when you are doing RAND-C, then what you are missing is, like, RAND-C is like a tool which people tend to overuse. It, like, first of all, it makes the solvers do completely wrong thing. Like, for example, there are 4 variables, right? And there are constraints between all those 4 variables, and all the 4 variables you also make RAND-C. Okay, then RAND-C has a way of solving of randomization. So if you are making a particular variable RAND-C, then it is going to randomize that variable first, and then look at the rest of the constraints. Okay, so RAND-C breaks the constraint ecosystem in that way. If there are 4 variables and you are making one of them RAND-C, then, for example, let's take a simple example. You have variable A, which is Boolean, and variable B, which is a byte, and both of them are random, right? And then there is a constraint. If A is true, then B is equal to 0, right? So when A is true, B is B is bound to be 0, but when A is false, B can have any of the 256 values.
Yes.
Okay. Now, if you are saying something like solve A before B, then A will be randomly, will be uniformly distributed. It will have true, false, and whatever, right? It will be almost 50-50%. But B will not be uniformly distributed because half the times it will have value 0. Okay, but if you don't have solve A before B, then there are 257 possible scenarios, and those 257 possible scenarios will be randomly or uniformly kind of hit. Okay, therefore, having A equal to true will be only 1 in 257 times. Okay, so now if you want to do solve A before B, then you have enough knowledge about the system and you want to do it. But what I'm trying to say is RAND-C is usually misunderstood. So it has an inherent solve A before B kind of characteristic, first of all. Secondly, it is worse than solve A before B because without RAND-C, if you just put solve A before B, then true is possible for A, right? If A is Boolean, then 0, 0, 0 or 1, 1, 1 is possible. With RAND-C on A, 0, 0, 0 is not possible. 0 or 1 will be repeated can only be at max repeated twice. 0, 0, 1, 1. But it can't be 0, 0, 0. So transition coverage will be skewed. Right? I mean, transition coverage in the sense that you may have written some transition coverage matrix, but there is an inherent transition coverage, right? Which you haven't done in your functional coverage, for example. It could be like what I'm saying inherent is 0, 0, 0 is actually possible and it may lead to a bug. So with RAND-C on A, 0, 0, 0 becomes an impossibility. So you are hitting functional coverage because functional coverage you have manually written and you didn't have 0, 0, 0 as a transition coverage. So RAND-C should only be used when you know the system has an inherent RAND-C characteristic. So that's where you should be using RAND-C in the stimulus. Not because of meeting as a tool to meet functional coverage.
All right.
Okay, I can tell you two more reasons why RAND-C shouldn't be used. One of the reasons being RAND-C puts a lot of memory, memory overhead because when you are not using RAND-C, then you're just using a global random seed. And if you are using RAND-C, then that global random seed is there, but there is a local random seed for every RAND-C variable. Another reason is the way stimulus or test benches are written these days. You have a transaction and you are randomizing that, right? That's how people write test cases. Okay, if you are making one of the fields RAND-C and you are randomizing the object, then since you are randomizing different objects, the RAND-C actually doesn't hold. So people don't know about it and they keep using RAND-C. RAND-C can only hold if you have one object and you are calling randomize on it multiple times. But if you have multiple objects and you call randomize on each one of them separately, RAND-C doesn't hold.
So that means like when if the active critic method for reinforcement learning for verification in this case to be used, then this principle is to be taken care because functional coverage cannot just completely rely us to
It's
actually
only
have.
a matrix. It cannot be the only goal.
Yes, so but then that could be used. So functional coverage report can just be used to see how much of the randomization the test has been able to cover and how fast the values were to be reached. And if, when you mentioned instruction renaming, instruction ordering, so even if you speak of uh, out of order execution, so again those values could still be passed on to the microarchitecture and will be passed on to the design. The functional coverage infrastructure for all of that could still see those values being covered.
Yeah, but I mean, look at for example, the latest processor from Sci5. I think it has 1078 depth of instruction reordering queue. Okay, so you can't have a functional coverage matrix which can cover all kinds of randomization in that 1078 depth of queue. So that's what, like, the best way to find bugs, especially in complex systems, is to just let the randomization be. Just let it do whatever different scenarios it's generating. So I actually, like, I would even say, because there are SAT SMT solvers also involved, and they are not completely random. So I would actually say the best possibility is to involve as many tools as possible, just so that maximum randomization can be achieved. Because each tool is going to have its own randomization engine.
Yeah, right.
Yeah.
Yeah.
Yes.
So yeah. So the next thing will be the hardware security verification. So this basically involves a Trojan detection and see whether any malicious function has implemented in design. So I think this is another aspect of verification. So in right side I have provided the link. So I think it will be a good start to learn about how hardware security verification works. So and there is also a hackathon which happens every year, called the Hack Attack. So where they will give SOC, they will inject a Trojan, and the goal is to, like, we have to find the Trojan and we have to file it. This thing. So it will happen every year. So I think this year they have selected Open Titan as a SOC. So there they have injected. Trojan, and the team has to find Trojan, and they have to file it to the committee thing. So whoever finds the correct Trojan, they will get to be a winner on this one. So I think there is a GitHub repo for this hack deck also, so we can refer previous year's hack deck and see how they have found the uh, how they have found the Trojan in SOC or IP level. So it will be a good learning to know how hardware security verification works. Yeah. Can you move? Next slide, please. So we are just planning on community project. So one thing will be take a system Verilog and try to write an example for all the features, so that we will get familiar with all the SV features, keywords. So it will be good practice for a beginner to learn. And next thing is we are planning to do RISC-V CPU design verification. So we're just planning to create a template in UVM or PyUVM. So where you will pick up a RISC-V design, use this template to generate a test bench, and give a run and verify it and publish in the GitHub repo. So this is under development. I think plan to work. I will take some help from Sandeepan to for this CPU design verification. And once it's done, we'll let you know, and you guys can give a try for this one. Can you go to next, please? So finally, this GitHub is a new resume. Try to work on as many projects as possible and make it open source and make it so that it will help your visibility in LinkedIn or any social platform. And for regarding the using of GenAI or LLM, try to explain or review stuff. For beginners, don't use it for coding. You try to code and you review with LLM or use mainly for reviewing or explaining the stuff using GenAI. And another thing is like try to code every day. So, and final thing is like try to develop a hybrid knowledge. So having expertise in one field is not enough. Since with the rise of LLM, right? So it will be quicker to learn any new area using ChatGPT or Google Gemini, anything, right? So that we can so that having expertise in hardware is not enough. So we must try to develop expertise in software so that we can try to work with new framework. So it will be useful to develop a new framework and have new view on hardware design verification. Yeah, I think that's it. Next slide, please.
Yeah,
Yeah.
it was a very insightful session. Thank you for joining today's session. And we will be coming up with more such insightful sessions ahead. So have a good day ahead, a good night, and good morning to people who have just now who are from USA and other time zones.
Yeah, Anshka.
Yeah, Paul Sherman, do you have any questions?
Okay.
Yeah, hi Anushka. Hi everyone. Here in San Jose, California, it's about what 9 a.m. Did you get my questions earlier, Anushka? Or should I read them?
Yeah, your voice is a bit slow.
Just a few thoughts for everybody. Good, thank you for everybody presenting here today.
Thanks.
I'll put them in the chat. Let's just start. I'll read a few. Maybe would be fun to describe in the panel among all of you. What is the difference? Well, first of all, I like your summary. That means realize that firmware is really both hardware and software, and being successful in what design you're doing means being conversant both in hardware and software. You know, a good question is firmware, is it hardware or software? It's both or it's neither.
Paul, I meant to say that software is like suppose if you want to use reinforcement learning, right? So we need to know Python program language is a software language, right? So what I
Yes,
meant is like it's not a firmware. So I mentioned like software program language, so that
yes.
suppose if you want to implement reinforcement learning or machine learning in our hardware verification, right? So we need to have expertise in those software languages so that it will be easy to integrate or use it in our verification environment. So that's a final thought on this hybrid knowledge.
Yeah, hybrid, very important. Yeah, not only Python, but scripting language, even some fluency in Bash or C Shell or DOS batch file, scripting language or all kinds of things. You know, down to being conversant with high level language. Um,
Right. Yeah.
yeah. So one simple question going back that I see a lot of people struggling with, and I know I've seen different labels of titles in startups that I've been at. What's the difference between validation and verification, and what's the difference between verification and certification? Two different things. I'll type that in.
There is some noise, right? Can
Somehow we lost him.
No, I'm here. I'm just typing in.
Oh, yeah, sorry.
So Paul, just to answer you, validation is post-silicon. Once the chip is back from the fab, you want to run certain tests on it to make sure that it works and there are no bugs in the silicon. Uh, Usually, the validation tests run much faster than pre-silicon tests. So validation is much more, I would say, like for example, you can run an actual chip for hours, and that kind of test, if you are doing in simulation at pre-silicon level, then that won't complete in years. Okay, so validation is much more thorough, but it is post-silicon, and verification is pre-silicon.
Yeah, some people uses the terminology pre-silicon validation, post-silicon validation. That's why. Yeah.
Good term.
Okay, certification is usually done by certain agencies, and mostly it is done on a finished product. So, for example, you will have certification regarding functional safety, as well as certification regarding whether you are meeting the standards of, say, a particular WLAN, wireless LAN standard. Okay, so but verification is again like it is specification based and it is project based. It's not that there is no like there's no central agency which is going to give you a certificate that you are complying with the particular standard.
Yeah, to add a point from my side, once you have done the verification, just it helps in chip sign off. But the certification, including the third party agencies, in when I was working with microchip, the ISO people used to come, and they even see the documentation, specifically the chips which are going to the medical domain, like pacemaker and those. They're very particular on that because it is going in human body and determine their life. So uh, they has to involve and see documentation and their validation, their result, everything they will thoroughly verify. We as a verification engineering, we can sign off and we are done, but after coming the chip and it is going on some critical defense or a human body, this kind of agencies will involve and say that this is thoroughly done, as right from the documentation to software, to the validation level, all the levels. So I have seen this procedure. So that's why a third party ISO certified agency will do this in USA actually. But I'm not sure in India how does it done. But yeah, in USA ISO will do that.
Yeah, that was very good. A very good description there. Whether talking about whether the process is agnostic to any agency or specific. That's very good. Kind of touches on the next question I'll put in the chat. Who sets the test suites you use as a verification and validation engineer or team? How standardized are the tests? Kind of, touching on what you just described.
So Paul, as far as RISC-V is concerned, for example, there are some tests which are called compliance tests. So those are standard and everyone uses those to make sure that they are compliant with RISC-V instruction set architecture. But those are only for compliance. So they don't necessarily bring out bugs in your microarchitecture specific bugs in your system. So the tests which you run for microarchitecture verification, those are randomized and there's no standard about those. And everyone has their own way because everyone have their own microarchitecture. So they write their own tests to verify those, the microarchitecture.
Yeah, good. Y'all type the next question.
So I think it's done for today. Thank you for joining.
Yeah. In your and the last one is kind of humorous. Can leave something with everybody kind of laughing. In your daily work, do you usually have more trouble with folks from downstream implementation and manufacturing, or do you have more trouble when you're working with upstream research and development? Said another way, which side, which side of an organization do you have a more symbiotic relationship to?
It's not audible. Can you repeat the question? You're typing something?
Yeah. Let me. Yeah, not too good a connection.
These are really excellent questions coming up. So I thought we can continue another session when Anushka comes back and arranges one thing. And I think if you have some place where we can share this question together and have more thoughts on this, and maybe in LinkedIn or somewhere in a common emails we can share these questions actually.
So let us end the meeting for today.
All right, I think the time is up. So
The anchor has left.
so maybe those last question I haven't heard back, but we can discuss in our maybe next podcast, I think. Anushka
Okay.
left.
Yes, indeed. There they are. That's kind of funny.
Yeah.
I've worked in test engineering in the hard disk drive industry for 3 decades. Seagate, Western Digital, and as a test is a 4-letter word, TEST, similar to other 4-letter bad words. And I in all of my career experience, sometimes I get more trouble from manufacturing downstream, which is pushing yield, and sometimes I get more trouble working with R&D and design engineering, which is pushing performance. They want ultimately unobtainable tight tolerances and specifications. And so in the same way as a validation, pre or post silicon testing, validation verification, everybody here that's listening to this call and good talk, should think about, do you have a better, easier working time with the back end or the front end of development?
Paul, as far as verification is concerned, it's always front end. So you can take it this way, like these days, the designs have so many bugs that you usually need, for complex systems, you need up to 4 iterations before you come up with a design which is bug-free or which is workable. not bug free.
Wow.
Um,
Well,
so if your design is failing, then there is no validation. Like if your design has bugs which make it unworkable, then yield doesn't mean anything because your chip is unusable. On the other hand, if your design is working, then only the yield factor comes in. So as verification engineers, we are more concerned about front-end issues or design issues. Uh, and validation people are also like the bugs which are not caught in pre-silicon verification. A lot of those bugs will also be inherited by validation team, but they're also worried about the yield and DFT and the clocking issues, for example. But as far as the verification team is concerned, we are mostly working with microarchitecture level issues.
Yeah, good point. And also, you mentioned yield clocking, and one big issue I've seen a lot of teams struggle with is the out of band stuff, the reset properties. What happens when you're starting up a link or starting up a core? What happens when you press reset or go into sleep, get out of sleep? A lot of people, a lot of teams and the designers kind of overlook the startup. How
Yes.
long does it take to get things going? Sometimes numbers of seconds, right?
Yeah. So those are the things which are usually like there are people who are taking care of the PLL, for example,
Right.
and the reset circuitry. So that's a separate team. Mostly like when we talk about verification team, we are only talking about functional verification, not related to, for example, things about reset and the PLL.
Mm. Clock path, power domain, things.
We do have something related to the cross domain clocking, that kind of issues, which we can handle somewhat in gate level simulation. But again, like our main focus is on micro architecture level debugging.
Sure. Thank you, Anushka, for getting us all together.
Yeah, please, Vivek, go ahead with your question if you have.
Vivek, it's probably be the backend, which will be much more driven by AI, because the backend has much more data in terms of like every project becomes data as far as AI is concerned. The backend. So for example, the backend will be done almost the same way, irrespective of your microarchitecture. Okay, so there is lots and lots of data available when it comes to backend, and therefore AI has much more opportunity there. On the other hand, when it comes to front end, then across domains, there are going to be so many different microarchitectures, and also that the complexity of those microarchitectures cannot be localized. Like in backend, you can, for example, look at a certain part of silicon, maybe which is a micrometer sphere, and try to analyze that. In microarchitecture, you can have a much bigger depth of complexity. Okay, the complexity in microarchitectures can be much more. Okay, so therefore, I would say that's the difference between when you are doing backend, or what you call PD, then you use scripting languages. So see, Python is a scripting language, and therefore AI will be much more applicable over there. On the other hand, when you are talking about front end, then you are talking about more about programming and logic. So AI will be having applications there, but not to the scale of backend.
Megwant, your question.
Yeah, is it possible? Is it possible for LLMs to really, is it possible to train the uh, backend stuff?
Yes, uh, but I would rather say there is nothing to be afraid of. The human mind, like it has always been afraid of. For example, uh, when the ceiling fans were introduced, a lot of people said, okay, they'll be taking away jobs, so they wanted to use hand fans, right? So the human mind also evolves, and it has the way of abstracting over on top of other things. So there'll be jobs which will be at higher abstraction level for the humans to handle. So rather than looking at AI as a rival, we need to look at it as a tool.
Currently, I'm a second year student from college in Hyderabad. Uh, they have started with AMD Vivid software and MATLAB and a few other softwares. Uh, what would you suggest? Till now, I got what you was trying to say about doing some projects in GitHub and all those, but the roadmap was a bit blurry.
My advice is do what you enjoy, but make sure, like if you are in coding, whether it's MATLAB or C++ or Python or whatever, make sure you are doing enough coding. Okay, so long as you are coding, you will be learning. If you are coding in C, then later you can code in Verilog or MATLAB or anything else. But the end objective should be to learn how to code. So if you are doing enough coding, but the important thing over there is you should enjoy that. If you don't enjoy coding, pick up something else. Okay.
I would also like to add a point in response to your question, Mitranan. When you asked that whether LLMs can be trained with backend data, I believe they can be. A couple of years ago, some researchers from Google came up with a deep reinforcement learning algorithms for layout applications. So I believe so when you have all the data for the gates and other values like W by L ratio, and so those are all, I guess, so those values are all available from the macro libraries which the engineers basically use. So I believe those can be used and then could be used to train the model. If you want to go in the direction, uh, uh, you can also learn machine learning in parallel, like at least some supervised learning, that how regression is done, how classification is done, to have some interest in that domain, and then you can work on that.
Thank you. Thank you. Bye-bye.
Uh, so if we do not have any questions, are we free to end this session?
Actually, you spoke about C and Python, but I also mentioned AMD Vivid. What would you say about that?
Is it about a backend?
Yeah, yeah. It's a ver Verilog verification. They have started. They showed us to a new software called AMD Vivid or something like that. Do you guys know some anything? I mean,
Are you talking about the GPU-powered simulation platform that AMD recently announced. So it's an RTL simulation platform powered by GPU. Is it? Or is it some AMD Vivid the other way? It could be some Xilinx FPGA platform. So I'm not sure what you're talking about.
It's
Oh,
AMD
maybe you
Vivid
talk about
designing
AMD
software.
Vivado. Are you talking about AMD Vivado?
Yeah, sorry.
Okay, yeah. So it's just a platform. Like you use a platform, but the objective about learning shouldn't be the platform. It should be the language. For example, if you are interested in front end, the objective should be RTL and verification, which is mainly system verilog or anything similar.
Thank you, sir.
Vivek, please go ahead.
Vivek, the only way is solving logical problems and coding. So the only way is to evolve your mind. So that's all people look for. Like they just want you to be a good problem solver. So that's what people interview you for. So as Paul is recommending, The Practice of Programming by Kernighan and Pike, that's a very good book. But also, like, keep it in mind, first you need to also learn some book from the basics, like everyone, whether he's doing Verilog or system Verilog. So they should know C as a, as a necessity. So learn C language, and again from Cunningham and Pike. Then practice of programming it's slightly at a higher abstraction. So yeah, that's what I would recommend. Like learn how to code, irrespective of what you are coding in, and you prefer to code whatever you enjoy. So if you enjoy Verilog, if you enjoy Python, if you enjoy C, whatever, you should choose that. So Paul is asking about Scala or Chisel. Paul, like what people are trying to figure out is, because Scala is just one of the platforms, there is also BlueSpec, and especially some companies are finding BlueSpec to be slightly better than Chisel in terms of what you can do with that tool. With Scala, the learning curve is also much higher. So typically that's one of the problems with Scala and Chisel actually. The learning curve is pretty high, and what some people are saying is, like, to be productive in Chisel, it may take you a year or more. BlueSpec is also a license-free tool, and it's much closer to system Verilog. So a lot of people prefer that. CHIPS Alliance group, as far as that group is concerned, there are some good projects out there. They are implementing a vector processing block. They also had some projects on verification. But again, even if the CHIPS Alliance group, even if they are doing open source, the problem I faced personally with them is they don't let you in easily unless you are one of the member companies. So it's difficult. Like you make a pull request and there is no response unless you are one of the member companies. So that's one issue I personally faced with Chips Alliance.
We have also one more question by Yogesh. He wants to pursue masters in VLSI.
Okay, so I would want to answer that. Most of the places where they are doing master's program in VLSI, they are at device level. So there are very few places. I mean, you can count them on fingers. For example, IIT Mumbai, or there'll be IISc Bangalore or IIT Madras. So maybe 3, 4 more where they'll be letting you do something at architecture level. Otherwise, most of the people, if you're doing masters, they don't have good professors who can like handle architecture level stuff. So they will make you do something at device level. So again, that's something. Okay, US universities completely no, unless you want to be thrown out after 6 months or so. I mean, that's a personal advice. The situation is going out of hand in US universities. So, I mean, the other situation, like being that kind of white supremacist environment, that is one problem in US universities. The other problem is the funds are drying out. So the government is not releasing funds for the universities, and even otherwise the funds are drying out. So that's a problem over there. So I don't know what you mean by my main area is thesis. Like you have to choose your domain. So like unless you know what you are going to work in, so you should not go for higher studies. Like you shouldn't be at the mercy of the professor, like whatever he gives you, and you are taking that as a research topic. You should know what you are going to research in. So unless you know what you are going to research in, you shouldn't be qualified actually to do the research.
So, do we have any more questions on the panel? All right, then I believe it's time to end the meeting. Thank you for joining. Thank you for being a part of this conversation.
Last, if we get any doubt, like maybe tomorrow or sometime, is it possible to make a group of some kind, like in Discord or something like that?
Aren't you part of the group, by Anushka?
No, no.
So then, how did you get to know about the meeting link then?
Uh, from my Balram Naik, my
Uh,
my uncle.
oh, okay, okay. So, please don't worry. You can join the group. Um, if I will ask, can you please try connecting with Anushka and she can add you to the group and then you can post your questions.
Some of the groups, Sandeepan, are full. Like WhatsApp allows only 1,000 people to join, and they're already full.
Yeah, I remember she said that. I guess she has also created a Discord server group. I need to ask her if she has posted.
Thank you.
So can you please connect with Anushka over LinkedIn? Maybe she could share you the Discord server link.
Oh, okay, okay. Thank you. Thanks.
And also in closing, remind everyone next month or in October, the RISC-V Summit, North America, Santa Clara, California. Um, if you can't be here, maybe there's some virtual, but that's also a lot of discussion too.
What are the hotshot topics you are expecting in the summit?
How's that?
What are the updates for RISC-V we are expecting in the summit?
Mm, it's pretty much all on the website. There about a full week of conference activities, developer. There's a developer zone. I think there'll be a hands-on workshop of different speakers, Google, Siemens, all that, and just good. It's a good interaction. Andrew Waterman is always a lot of fun to meet and talk with, and just it's the good part of the RISC-V community is always there.
So virtual is available here? Virtual is there or it's fully?
Physically.
Oh.
Yeah. And hopefully it's not hard to travel. I know Lori Servin and Megan Lynn and the RISC-V Foundation people always very helpful for helping get folks to travel. I know that's an issue, but an in-person meeting, yeah. Look on the website. Yeah, Anushka should be able to tell people how to do that. She's a RISC-V member like myself.
Sure thing, we'll check up with that.
Yeah. Two names: Megan and Lori Servin.
All right. So, all right then. Shall we end this discussion now?
All right.